Every single human on Earth today descends from people who had dark skin. Not tan, not olive. Deep, rich brown skin built for a life under the blistering African sun. Though here's the real mystery. If we all started out that way, why do some of us now look like we've never seen daylight? Why did evolution paint some of us pink, some of us golden, some of us the color of dark coffee from that one shared starting point? To understand skin color, think about our skin as a kind of shield. Well, sunlight carries ultraviolet radiation, and it's a double-edged sword. On one hand, too much of it damages the DNA inside our skin cells, which can lead to dangerous mutations and skin cancer. On the other hand, our bodies need a little of that same radiation to make vitamin D, a nutrient that keeps our bones strong and our immune system working. Skin color, it turns out, is our species' ancient solution to balancing those two competing demands. Well, the actual mechanism comes down to a pigment called melanin. Now, it's produced by special cells in our skin, and it acts like a natural sunscreen. Here's what's fascinating, everyone. Regardless of skin tone, has roughly the same number of these pigment-producing cells. The difference isn't how many you have, it's how active they are, and what type of melanin they churn out. People with darker skin produce more eumelanin, a type that's extremely good at absorbing and blocking ultraviolet rays before they can damage the DNA underneath. Around 2 million years ago, our ancestors lost most of their body hair. Alright, that's huge, because thick fur had protected earlier hominids' pale skin from the sun for millions of years. Without that fur coat, exposed skin near the equator faced brutal, direct sunlight almost daily. Natural selection responded quickly. Individuals with more melanin were better protected from skin cancer and from a dangerous breakdown of folate, a vitamin essential for healthy reproduction. So, dark skin wasn't just common, it was the only viable option for a hairless primate under an equatorial sun. Now, here's where the story gets interesting. Starting around 70,000 years ago, groups of humans began migrating out of Africa, spreading north into Europe and Asia. And immediately, they ran into a completely different problem. The further you travel from the equator, the weaker and more slanted the sunlight becomes, especially during long, dark winters. Suddenly, that thick coat of protective melanin wasn't a shield anymore. It was a liability, blocking out sunlight that people desperately needed to make vitamin D in their skin. Imagine trying to charge a solar panel covered in dark-tinted glass during a season when the sun barely rises above the horizon. That's what was happening to early humans in northern latitudes. Populations that stayed dark-skinned in low sunlight regions began suffering from vitamin D deficiency, weakening bones and causing rickets, along with serious pregnancy complications. Over thousands of generations, natural selection quietly favored anyone whose mutations happened to lighten their skin, letting more of that precious ultraviolet light sneak through to make vitamin D. Here's a fact that surprises almost everyone. Genetic evidence suggests that very pale skin is remarkably recent in human history, emerging within roughly the last 12,000 years. Wait, in fact, some ancient European hunter-gatherers who lived less than 10,000 years ago still carried the genes for dark skin alongside strikingly blue eyes. Pale skin wasn't some ancient default. It was a fast, localized adaptation, and it happened independently multiple times in different populations across Europe and Asia through completely different genetic mutations that landed on a similar solution. And that's honestly one of the most beautiful parts of this story. East Asian populations evolved lighter skin through different genetic changes than European populations did. Two separate groups, facing a similar problem of low sunlight, arrived at a similar answer through entirely independent paths. Scientists call this convergent evolution, and it shows up throughout nature, like how both bats and birds independently evolved wings for flight. Skin color across humanity isn't one single story branching outward. It's several parallel stories, each shaped by local sunlight, each arriving at solutions that worked. Now, if less sun simply meant lighter skin, you'd expect the palest people on Earth to live in the high Arctic. But populations like the Inuit, who live in extremely low sunlight regions, kept notably darker skin than many Europeans at similar latitudes. Why? Because their traditional diet, rich in fish and marine mammals, was already packed with vitamin D. When your fruit supplies enough vitamin D, your skin doesn't need to lighten to catch extra sunlight. That single exception proves just how precisely tuned this whole system really is. So which genes are doing this work? Researchers have identified several, and one of the most important is called SLC24A5. Wait, a single change in this gene is linked to much of the skin lightening seen in European populations, and a version of that same gene independently helps explain lighter skin in some East African and Middle Eastern populations too. Other genes, like MC1R and OCA2, add further layers, shaping everything from freckling patterns to reddish tones in some populations' skin. Here's a wrinkle worth sitting with. Skin color doesn't map perfectly onto distance from the equator. Some populations in high-altitude regions, like parts of the Andes and the Tibetan Plateau, have moderately dark skin despite living far from the tropics, because intense ultraviolet radiation at altitude mimics equatorial sun exposure. Meanwhile, heavy clothing, time spent indoors, or diets rich in vitamin D can all shift the pressure natural selection applies to a population's skin tone over generations. So here's a thought experiment. What if humans had never left Africa at all? Actually, in that world, nearly everyone alive today would likely share a similar deep brown skin tone, and the very concept of racial categories based on skin color simply wouldn't exist in the way it does now. The pale skin, the freckles, the golden undertones we associate with different ancestries, none of it is fundamental to being human. It's a temporary, local adjustment layered onto a species that started, and biologically still is, fundamentally African and fundamentally dark-skinned. Honestly, this is where biology collides with history in a heavy way. A trait that evolved purely to manage ultraviolet exposure got turned, especially over the last few centuries, into a basis for social hierarchies, colonization, and deeply unjust systems. Scientists are unambiguous on this point. Skin color reflects a handful of genetic variants responding to sunlight, nothing more. It carries no connection to intelligence, ability, or worth. Every serious genetic study confirms that the variation within any single population is far greater than the average differences between populations. In fact, genetic studies consistently show that any two humans chosen completely at random from anywhere on the planet are about 99.9% identical in their DNA. Skin color involves just a tiny handful of genes out of roughly 20,000. We built entire social structures around one of the most genetically minor traits our species has, while sharing the overwhelming majority of our biology, our capabilities, and our humanity in common. There's even an economic angle here. Historically, agricultural societies near the equator built calendars, architecture styles, and clothing traditions around managing intense sun exposure, while northern farming societies solved the opposite problem, maximizing scarce sunlight for both crops and human vitamin D needs. Seriously, skin tone adaptation was one small piece of a larger puzzle every human population solved locally, whether that meant light-colored buildings that reflect heat or clothing that let in a bit more winter sun. Before sunscreen came in bottles, melanin was doing that exact job for free, built directly into your skin. And in a strange twist, modern life has scrambled the whole system that evolution spent tens of thousands of years fine-tuning. Many people today live indoors, wear sun-blocking clothing, and travel across latitudes in a matter of hours, so our skin often no longer matches the ultraviolet environment it evolved for. That mismatch is part of why doctors now recommend vitamin D supplements for so many people, regardless of their skin tone. Consider someone with deeply melanated skin who moves from a sun-drenched region near the equator to a cloudy northern city. Their skin is still doing exactly what it evolved to do, protecting them from ultraviolet damage. But in that weaker sunlight environment, the same trait that once offered vital protection can now contribute to lower vitamin D levels, unless diet or supplements fill the gap. It's a vivid reminder that a trait shaped by one environment doesn't automatically fit a different one. And here's something almost everyone has personally experienced, even if they never thought about the biology behind it. Actually, when lighter skin is exposed to strong sun, it darkens temporarily, a process we call tanning. That's the skin producing extra melanin in real time, as an emergency defense against ultraviolet damage it's detecting right now. It's essentially the same evolutionary tool our ancestors relied on over millennia, just compressed into a response that plays out over a matter of days instead of generations. This mismatch has real consequences today. Populations with lighter skin, whose ancestors adapted to weak, high-latitude sunlight, now face significantly higher skin cancer rates when they live in or vacation in intensely sunny regions their bodies never evolved for. Meanwhile, people with more melanin, while better protected from ultraviolet damage, are statistically more likely to have undiagnosed vitamin D deficiency in northern climates. Neither situation reflects a flaw in anyone's biology. It simply reflects bodies operating in environments quite different from the ones that shaped them. Researchers are still uncovering new genes involved in this story every few years, and some of the timing questions remain genuinely unsettled. Honestly, scientists continue to debate exactly how quickly certain populations lightened, and precisely how big a role diet, clothing, and shelter played compared to raw genetics. This isn't a closed chapter of science. It's an active, evolving field, and every newly sequenced ancient genome adds another piece to a puzzle still being assembled. So where does this leave us moving forward? As global migration accelerates and populations mix more than ever before, skin color variation within families and communities will only keep increasing. Some researchers speculate that, over an extremely long timescale, humanity's skin tones may continue drifting and blending in ways shaped by travel, diet, and intermarriage, rather than by any single localized environment. Our story with the sun isn't finished. It's simply entering its next chapter. So let's bring this back to where we started. Well, every shade of human skin, from the deepest brown to the palest pink, is a variation on the exact same theme, one species finding different local solutions to the identical ancient problem of surviving under the sun. Different shields, same sunlight, same species underneath every single one of them. So the next time you notice how different two people's skin tones look standing side by side, remember what that difference actually represents. Now, not separate origins, not different value, just one shared human story, written in slightly different ink, by the same sun, on the same species, going back to the very same African ancestors we all come from.